Going down a little bit, we are trying to find the missing side on each of these triangles, and we want to leave our answer in simplest radical form. Now you might recognize these as right triangles, which means that we can use a good old Pythagorean theorem. Now Pythagorean theorem, we always remember, is a squared plus b squared equals c squared. So one of our legs is a, one of our legs is b, and our hypotenuse is always going to be the c. So in this first problem here, we want to figure out what x is. We need to make x our c. We need to make one of these our a and one of these our b. So we plug those all into the equation. We get 9 squared plus 11 squared equals c squared. 9 squared is 81. 11 squared is 121. Still equal to c squared. Add those two together and we get 202 equal to c squared. And then we take the square root of both sides because we want to undo the square that we have on c. So that's going to cancel each other out over here. So we're just left with c on this side. Now you might be thinking, well, where's the plus or minus? Well, typically, yeah, we would use a plus or minus, but we need to think in context of what we're actually doing. We're solving for a hypotenuse. A hypotenuse is a length, and we don't have negative lengths. So in the case of a triangle, we are only going to worry about the positive. So the only solution we care about is a positive one. Now it says leave your answers in simplest radical form. And that's what we were practicing earlier when we reduced that root. So once we have this, we need to break this down best we can into the simplest root. So I'll start out, I know it's an even number, so I can divide by 2. And now it turns out the number 101, despite being a pretty big number, you try dividing it by all kinds of things up through 10, and you'll realize that it's actually a prime number. So there is nothing we can do. There are no common factors we can get out of this. So our final answer in simplest radical form is going to be this giant number, the square root of 202. And that's c, which in this case is actually x. So I'm going to draw a little arrow to that. Let's try one more problem here. If we go down to number 8, we can do the same type of thing. So we have a squared, and we're going to make that a. We have plus b squared, and that'll be our b, equals c squared. So we have 4 squared plus 6 squared equals c squared. 4 squared is 16, 6 squared is 36. We add those together and we get 52. And then we square root both sides. Square and square root undo each other. Square root over here, we only care about the positive because it's the length. And we want to reduce that radical as much as possible. So factoring it out, I know I can take a 2 out because it's an even number. And when I divide by 2, I get 26. And 26 is even, so I can divide that by 2 and get 13, and 13 is a prime, so I can't go any farther there. But these 2's, that pair of 2's can come out front as a single 2, leaving me with just that 13 under the root. So I now have 2 root 13 as my answer, and that will be my x. And finally, let's do one more example down here where we don't have a picture. It says find the missing side of each right triangle. C is the hypotenuse, A and B are the legs. Leave your answer in simplest radical form. I always like to work with pictures. I find it a little bit easier, so let's go ahead and draw ourselves one. So here's our right triangle. So this is side C, which is 12. We have side A, we'll say over here, which is 6, and then we have side B, and we don't know what B is. But I do know that a squared plus b squared is c squared, so 6, which is a, squared plus b, which is unknown, equals c squared, which is 12 squared. Now I work out what I have. 36 plus b squared equals 144. 12 squared is 144. And now you'll notice that the b squared is in a weird spot. It's not on one side all by itself, so we need to get it alone first before we can try to take any square roots. Do not try to do that. Bad idea. Because what will happen is you're actually taking the square root. It's almost like foiling, where you run into weird problems when you take that square root. So let's get rid of that. Go one more step and subtract 36 from both sides. So b squared equals 112. Now we square root. Things cancel each other over here. And the square root of 112, let's see if we can reduce that. It is an even number, so I will always be able to divide it by 2, and I get 56. From there I can divide it by 2 again and get 28, I believe. And then I can divide that by 2 and get 14, and divide that by 2 and get 7. So I have my pair of 2's, and I actually have another pair of 2's that both come out front. And then I have my leftover 7 here. So if I were to rewrite all of this, I would clean it up to 2 out front times another 2 out front times the square root of the 7 left over, which is 4 square root 7 for our b. That will be our third side. So the rest you're on your own with.